So this is a video on section 4.2 going over exponential functions, and we are going to be doing a bunch of problems focused on the future value of money. So this is finding what the value of from it. We take an initial deposit and we want to see what the amount of the investment would be in the future. So the equation that we use for solving problems like this, we use the equation called A equals P1 But what do each of these things mean? So let's label them. So A is the future value. So this is the value we're trying to find or trying to calculate. P is our initial deposit. R is the interest rate, so the annual interest rate. And we want this in a decimal, not a percentage. N is the number of times the interest is compounded per year. So the number of times the interest is compounded per year. And T, the last thing, this is regarding time, so this would be our number of years. So we're going to do a few examples of this with different ends. And before we do that, I want to give examples of what the ends could be. So let's say they say an n of 1 would be if they said compounded yearly or annually. And I know I went over this in the office hour, but we're going to do it again. N of 2 would be semi-annually. N of 4 would be quarterly. N of 12 would be monthly. And then if they said daily, it'd be the N of 365, because that's a whole year. So 365 days is a whole year. So now we have the basic setup and information to do these problems. Now, let's say they said compounded continuously. Well, if it says compounded continuously, that means infinitely. We can't use the original equation. So if they say in the problem continuously, we have to use A equals P times E to the RT. So we have to use a different formula. Same idea, just a different N. So we'll do a bunch using the first formula, and then we'll do one using the second formula. So, the first problem, let me write it down, then I'll come back. Okay, I'm back. So here's our first problem. So what we need to do is we need to read out the problem and then label what we have, and then we'll be able to solve. So they say, suppose you deposit $4,000 into a Roth IRA today. Determine the future value of the deposit if it earns 7% interest compounded semi-annually after 20 years. Okay, so I'm going to highlight my important key factors. So suppose you deposit $4,000, that's one of them. Determine the future value if it earns 7% interest. We're going to use that. And then it says compounded semi-annually for 20 years. Okay, we have our pieces. So they're saying find the future value of money. So I know I'm going to try to find A. But they tell me how many years. So we know time is 20. So I'm trying to find A of 20. So we don't know what our A is. We know what our time is. Then they say our initial deposit was $4,000. And then what else do we have? Well, we have to do our percent interest. So R, it said 7%, right? Well, how do I turn that into a decimal? So let's see. How can I do that? So what we do is we divide it by 100. So we just do 0.07 divided by 100 gives me 0.070. Then N is what is compounded. So it said semi-annually. Well, if we look back at our chart, semi-annually means that it's going to be 2. So I know my value for that is going to be 2. Now we can set up our equations. So A equals, what's our P? 4,000. 1. R over N. So R is 0.07 over our N. And then what's left? Well, we have to multiply N times T. So N is 2 times our time. Okay, so now I'm going to break this calculation apart. So I'm going to do the brackets first. So I'm going to do 0.070 divided by 2. That's 0.035 plus 1. So that's 1.035. Now I'm going to do the exponent. So 2 times 20 is 40. So now I'm going to do this together. So I'm going to do 1.035 raised to the 40. And that gives me this. And then I want to multiply it by my initial deposit. So what do we get? Times 4,000. We get 15,837.0. I'm going to do a tenths. So this is going to be 0. Since my decimal is 3/8, I'm going to round it up to 0.4. So if you have a number that's greater than 5 next to the number you're looking for in significant digits, you have to round up if it's greater than 5. So we know that A of 20 gives me $15,837.04. Okay, so now let's do another one. So what I'm going to do is I'm going to write down the next problem, and then I want you to try it on your own, and then come back and try to solve. So let me write down our next problem. Be right back. Okay, I'm back. So now I want you to try solving this. Break it apart, label all your pieces, and then see if you get the same answer. And make sure you break apart each step so that you don't make a mistake, because it's easy to with these problems. Okay, welcome back. So we know, let's look at our problem, let's label what we have. So suppose you deposit $2,500 into a savings account today. Determine the future value of the deposit if it earns 4% interest compounded monthly after 10 years. So we have $2,500. we have 4% compounded monthly, and we have 10 years. So I know I'm going to find A, and since I know time is 10 years, that means I'm going to find an A of 10. My initial deposit was $2,500. My R is 4%, so divided by 100 would give me 0.04. My N. Okay, so my N, since it says compounded monthly means that we have 12 months in a year, so it has to be 12. Okay, so now we're ready to set up and solve. So A of 10 equals okay, so we set everything up right. Let's see. So P is here, my R is here, my N is here, and then my N times T is in the exponential position. Good. All right. So now let's calculate. So I'm doing the brackets as I did last time. And then 12 times 10 gives me 120. Okay, then I do the exponential part. Then I multiply times 2,500. And let's see. Yep. So we get 3,727.081. So since there's a 1, I'm just going to make it rounded to 0.8. So we know the A of 10 is $3,727.08. Okay. So I'm going to give you two more, and let's see if you can solve them. Okay, so go ahead and try these two problems, and I'm not going to solve the work for them. I want you to try doing that, and I'm going to give you solutions as well. So go ahead and solve, and then I'm going to give you a few minutes to work on it, and then I'll show you the solution. Okay, welcome back. So the solution to 3 and 4, so number 3 is 12,643.09, and number 4 is 21,000. 169.35. Okay, so this was good practice for you guys. Now let's do one if it says compounded continuously, because we need to know how to do using the other formula we have. So the other formula, so let's do continuously. And if you were not able to get these two solutions, come see me and I can explain it to you in person. Okay, so let's do continuously. So that's A equals P times E to the RT. So let me write a problem for this one. But before I write the problem, I want to go over the E. So you guys already know what A is. You know what P is. That's our initial deposit. We know what R is. That's the interest. And we know that T is the time. But what's E? We haven't seen that yet. Okay, so E is actually called Euler's number, which is approximately 2.718. And if you were to look on your calculator too, we've actually used this button before, and it's where we have E to the box. So how we would use this button to put in our calculator, we would do press shift on our calculator on the upper left-hand corner, and then you would press the E. You'd press this button, which you'll find it just above where L ends. You'll have the LN button like this, and just above that, you'll have the E. Now that's on the Casio calculator. I don't know what it would be like on a Texas Instrument or another one, but this is what I have. So find that button that looks like that. Okay, so let me write out the problem and you guys we'll walk through it. Okay, so we'll go ahead and solve this. So suppose you deposit $5,000 into your account today. Determine the future value of the deposit if it earns 6% interest compounded continuously after 30 years. So if you notice, we have a different word. Continuously is here. So we have A, we have our T. So T was 30 years. So we're looking for A of 30. And then we have our R, so R is 6%. You divide by 100, and you get 0.06. So again, make sure you convert that 6% into a decimal. Because if you put just 6, then it will throw off your solution completely. So do we need anything else? Well, of course, we have our initial deposit. And that's it. So we don't have an n this time because we're using continuous. So yeah, we can label and say n is continuous, so infinity. But technically I only need to write that. So A of 30 with our initial deposit times E raised to the R, 0.06, times time. I feel like these are a lot simpler to solve. They're not as complex as the other one. So I'm going to multiply the exponents first. So 0.06 times 30 gives me 1.8. Then I'm going to do this together. So E, so shift, press the E to the box button, 1.8 in your calculator, and you should get 6.049647464. Now we multiply that by our initial deposit. And what do we get? So I get $30,248.237. So I'm going to round it up because it's a 7. And And that is our answer. Okay, so let's do one more. Okay, so here's another one. So let's label our pieces. Backtrack. A, we're trying to find A of what? So T is 18 years. So we're trying to find A of 18. Our initial deposit is $7,500. And our interest is 4.5%. Divided by 100, so that gives us 0.045. Now we just put it into our formula. Okay, now we just simplify. So 0.045 times 18 is 0.81. So E raised to the 0.81 is times our initial deposit so we get 16,859.0309. So I want to round that up. 859.31. So A to the 18 is 16,859.31. That is our answer. So that is how we solve for the future value of money.